Dear friends, I myself, Dr. Bharat Parab, discussing the topic mensuration. Under this topic, we are now studying area of trapezium. This is a trapezium, two sides are parallel, which is very important in this area. And see, WXYZ is a trapezium, okay? And the lengths of the all the sides are given. This is B, the whole thing is A, from B to X. This is T. Now this is a rectangle, so this is B, and base of this triangle is C. So after having a look at it, we'll now see the total area of trapezium, how to calculate. Okay. Now look at this. Total area of trapezium will be area of triangle WAZ, which is yellow one, WAZ, plus area of triangle BXY, green one, plus area of rectangle ABYZ, the red one, ABYZ. Okay. If you find the areas of all this and add, that will be the area of the whole trapezium. Okay. So we see this WAZ, this is base, height is h. So area of this yellow part is half C into h, plus the green part is half D into h, because this is D, plus rectangle B into h, B into h or here. Okay. Now we will split this B into h as half BH and half BH. Okay, for our convenience. So we write this half CH plus half DH plus half BH plus half BH, and now taking half H common from the big bracket, so we are trying to form the two brackets. Okay, taking half H common into this bracket, get C plus D plus B. You complete one small bracket plus this B aside. Got it? We have made this for our convenience because C plus B plus D is A, which is length of another parallel side. Okay, this is one and this is another one. Okay, so C plus D plus B is nothing but A. So we are substituting this value, and area is equal to half H into A plus B, that is half height into sum of the two parallel sides. Got it? That is why we have done all these calculations. Okay. So remember, area of trapezium is half into height into sum of the two parallel sides. Okay. So do remember this. Okay. Area of general quadrilateral. Consider the quadrilateral ABCD. ABCD. Draw a diagonal AC. Now from D, drop a perpendicular on this diagonal, so that this is height h1 for this triangle, and another perpendicular from this point on this diagonal, and height is h2. This is the height for ABC. Okay. The area of this quadrilateral is the area of triangle ADC and triangle ABC. This red one and green one. Okay. Total will be the area of the quadrilateral. So total area is ADC is half D into H1. This is base, plus half D into H2. Okay. Now taking half d common, we are left with h1 plus h2, where d is the length of the diagonal AC. Okay, got it? So this is the area of quadrilateral. Okay, move ahead. Now area of special quadrilateral, that is rhombus. Okay, earlier it was general quadrilateral, now this is special rhombus. So consider the rhombus ABCD. You know what rhombus is? You know the property that all sides are equal and diagonals bisect each other at a right angle. Bisect, remember the bisect. You may check the properties of rhombus, they are given somewhere. Okay. The area of rhombus, we are presently trying to find the area of this figure, rhombus. Area of rhombus is area of triangle ABC, okay, plus area of triangle ADC. If you add this, then that will be the area of the whole rhombus. Okay. Now, very interesting. See this area of ABC. This is base D2, and this diagonal is divided into two. That is, this is half of D1, and this is another half of D1, which is divided by this diagonal. Okay, so this much is half d1 and this much is again half d1. Okay, we have taken advantage of this, so area of this will be half into bracket d2 into half d1. Okay, plus area of this ADC is d2 into another half d1. Okay, very simple, very interesting, where half d1 is the height of the triangle. Okay, got it? So now take half d2 common. In bracket, you are left with half d1 plus half d1, that is d1. So here we are making this half d1 into d2 or d2 into d1, where d1 and d2 are the measures of diagonals. Okay. So now we tabulate all these formulas. Area of trapezium is half h into a plus b. You know what is a and b. Area of general quadrilateral is half d into h1 plus h2. This in the bracket. Okay. And area of special quadrilateral rhombus is half d2 into d1. Okay, where d1 and d2 are the measures of the diagonals. So need to memorize this. Okay, you read all these and memorize this by writing on paper several times and use them in problem while solving the problem. Okay, so we move ahead after this. Area of polygon. We are taking particular example of pentagons having 5 sides and try to calculate the area of this A, B, C, D, E. It's a pentagon, 5 sides. Okay. This is also a pentagon, A, B, C, D, E. There are two cases, two ways. Okay. So pentagon A, B, C, D, E, case 1. We divide the polygons or that is pentagon into triangles and calculate the areas of pentagon A, B, C, D, E as. Okay. Now look at it. So the area of this will be, now we have divided into triangle. Okay. So area of ABCD is area of triangle ADE, red one, ADE, red one, plus area of triangle ACD, ACD, yellow one. plus area of triangle ACB green one. ACB green one. Now we have the formula for area of triangle. Hence we can calculate the area of ABCDE or this polygon or pentagon, whatever it may be. Okay. So this is one way. Another way, case 2, we divide the polygon in parts as shown here, the straight angles and trapezium. Remember, this is one triangle, green one, this is blue one, this is yellow, and this is, remember, this is not a rectangle. This and this is parallel, so this becomes a trapezium. Okay, so we divide the polygon. We have seen this. So area of ABCD is equal to area of ADE, the green one, ADE, green one, plus area of QCD, yellow one, QCD, yellow one, plus area of ABP, blue one, ABP, blue one, plus area of PQCB, the red one, PQCB. This is trapezium. Okay. So we have the formula for triangle of area of triangle and area of trapezium. Hence, we can calculate the area of ABCD. We have formula for both this, and we can calculate the area of ABCD. This is one way. There may be some other also. Okay. So area of polygon in general. Now this is shown 5-sided, but if you have any number of sides, you can always divide them like this in triangles like this. Take one point and join all these. Okay, so pentagons and hexagons can be divided into triangles, and the areas of these polygons can be calculated by the areas of the triangle and adding them. Okay, so this is a general way of finding the area of polygon. So let us solve some problems on this topic. Okay, exercise number 1, read this very carefully. Find the area of rhombus whose side is 5 centimeter and whose altitude is 4 centimeter. Side is 5, all sides are equal for rhombus. Remember that. And altitude or height is 4 centimeters. If one of its diagonal is 8 centimeter long, find the length of the other diagonal. This has to be 8 centimeter. As look at it, this is a rhombus. We have drawn, see the answer. Always draw a rough sketch of the given figure and label as shown. Okay. Now we have this A, B, C, D label like that. This is center is O where a diagonal meets, and this is 5 centimeters. All measures are in centimeters. As he says, altitude is 4 centimeter, so this is 4. Naturally, this is also 4, and this diagonal is 8 centimeters. Okay, and we have to find the length of the other diagonal, this diagonal. Okay, like that, if you see, only if you concentrate on this triangle, then this is 3. Got it? Because this square plus this square equal to this square. Pythagoras theorem, 4 square is 16 plus 9, 9 which is 3 square equal to 25 which is 5 square. Okay, so like that its length is 6, but we have to find by other way. Okay, so to go through this channel, the area of rhombus, area of this rhombus is 4 into the area of AOB. All these are equal, so we have to calculate area of this and to multiply it by 4, so that we'll get the area of rhombus. So area of rhombus is like this. So we go 4 into half L into H, which is the area of a triangle. L is 3, L which is green is 3, H which is pink is 4, and this 4, so half is 2, cancel this 2, get 2. So this 2, this 3, this 4, get 24 centimeter square. Remember, all lengths are in centimeters. So this is centimeter square, 24 centimeter square. But the area of rhombus is also given by the formula half d1 into d2. So we have to use this formula, okay, where d1 into and d2 are the diagonals of the rhombus. So we write it here. Half d1 into d2 is equal to 24. So we know d1 half into d1 is 8, or is given here 8, into d2, which we have to find out, is 24. So if you cancel it here, you are left with 4, which goes here, the denominator side. So d2 is 24 divided by 4, which is 6. Okay, got it? Very simple arithmetic calculations. Therefore, area of the rhombus is 24 centimeters square, and the other diagonal is 6 centimeter. Okay, so that's it. Move ahead. So exercise number 2, second one, read this very carefully. The floor of a building consists of 3000 tiles which are rhombus shaped. Okay, rhombus shaped, and each of its diagonals are diagonals of this rhombus are 45 centimeters and 30 centimeters in length. Here it is very easy. Find the total cost of polishing the floor if the cost per meter square is rupees 4. Like that, if you try to understand this, this is very simple. Only you need to take some care. So we see that in answer. So answer, we need to find the area of one tile and multiply this by 3000. There are 3000 tiles, so total number of tiles to give the total area. Okay, till here it is again simple. You see this, the area of rhombus is equal to half d1 into d2, where d1 and d2 are the diagonals of the rhombus. Okay, we know this, but area here is given in meter square, that is per meter square is rupees 4. So we will convert this d1 and d2 this into meter, so that we get area in meter square. Okay, so if d1 is 45 centimeter, that is 0.45 meters, and d2 is 30 centimeters, that is 0.30 meters, convert in meters. Hence, area of one tile is half into 0.45, 0.45 into 0.30. Okay, now don't calculate at this stage, okay, because we have to multiply the whole by 3000. So we will do that stage also. So total number of total area, total number of tiles is 3000. So total area of the floor is equal to, this is the area of one tile into 3000 meters square, because these we are already converted into meters. Okay, so half into 0.45 into 0.30 into 3000. Don't calculate this at this stage also. Okay, you might get some benefit of keeping it as it is. You don't know. Okay, now if 1 meter square is rupees 4, then for all this we will see the cross multiplication. If now 1 m square is rupees 4, then this much m square total is x. Okay, This is equivalent to, see, 1 meter square is equivalent to 4, then this much area is equivalent to x, rupees x. So if you cross multiply this, if you multiply this with this and take it here 4, then you directly get the answer. So this rupees x will be, this 4 is here and all this will go there. So half into 0.45 into 0.30 into 3000 into 4. Simple. So to just take it there. Now you can calculate or cancel and do all these things. See, 0.45 is 45 upon 100. Now this is also 30 upon 100. So to cancel, these three zeros will go with this. This zero will also go with this. Okay. Now these two will go with this remaining two. So these 2 into these 3 into this 3 into 45. So 45 into what is that? This will be 90 into 9 is 99 810. Okay. So in the total cost will be rupees 810. Got it? So this is the answer. So as far as possible, don't try to calculate at your stage or in the beginning. Come till this stage and you can get a benefit of cancelling all this. Okay, there is no harm, but that may lead to some mistake. Okay, so after this we move ahead. Read this exercise number 3. Mohan wants to buy a trapezium shaped field. Its side along the river is parallel to and twice the side along the road. If the area of this field is 10500 meters square and the perpendicular distance between the two parallel sides is 100 meters, find the length of the side along the river. Need to read this very carefully. Now we will see, if sketch is given then no problem, but if it is not given, to draw a rough sketch so that you get better idea and better understanding of the data given. Okay, may not be up to the scale, it is never up to the scale, but you must have a rough sketch. So see here, this is a river, this is the road, and this is a trapezium shaped field. And what is given? Mohan wants to buy a trapezium shaped field if its side along the river, that is talking about this side, okay, is parallel to this side along the road, okay, and twice. That means this is twice. Remember that. Understanding this is very, very important. Okay, it's talking about the sides along the river, which is twice. So for this, generally we take this as x and this will be 2x. Then we'll find the value of x. Okay. If the area of this field is 10500 meters square and the perpendicular distance between the two parallel sides is 100 meters, that is this, that means it's giving you height. Find the length of the side along the river. See, this is also important. Okay, so answer, as area of the trapezium is given as 10500 meters square, we can write area of trapezium, which is equal to half h into a plus b, where h is perpendicular distance and a and b are the measures of the parallel sides. So you know this formula, a and b, that is, this is a, this is b, whatever it may be, and this is h. Okay, so a total here is given 10500 equal to half into h is 100 into, this will be x, and this will be 2x. We have to add x plus 2x. Okay, then we will get the value of x. So if you calculate it, these two zeros will go with this will be 3x. Okay, then this will go here and this will come down. So like that, if you see, this 2 will go there, that is here, 3 will come down, that is here. So if you 3 ones are 35, 2 into 35 is equal to x equal to 70. This is the value of x. Very easy. But we have to calculate the length of the side along the river. This, that is 2x. You have to give proper answer. Therefore, 2x equal to 140 meters river side length. Okay, this you must write. Okay, so that is why what is given and what is asked and proper answering is important. Okay, so this is that. Okay, fourth exercise, it is top surface of a raised platform is in the shape of a regular octagon as shown in the figure. Octagon means 8 sides. Remember, it is a regular octagon. Okay, you know the meaning of this. That's why every word in a problem is important. Okay, find the area of the octagonal surface. So this is given. See, this height is 4 meters, this is 11 meters, and this is 5. You know, when they are giving this is 5 and it's a regular octagon, it has 8 sides, that means all 8 sides are equal. That is the meaning of a regular octagon. Okay, so this is 5, so this is 5, so this is 5. This is 5 is very important for us, and this 5 is also important for us. Okay, this 11 is as it is given, so we proceed for the answer. We can see that the octagonal figure can be divided into, first one, two trapeziums having a length of parallel sides 5 meters and 11 meters. This is one trapezium and this is another one, congruent one, and two sides are parallel. This is 11 meters and this is 5 meters. As you know, this is a regular octagon. So this is 5, this is 5, this is also 5, so this is also 5, and this is 11 meters. So we have this length, and this is given 4 meters. So we can calculate the area of this. Similarly, if you multiply this also will be the same as this, and if you multiply this by 2, you can cover this area. And this is a rectangle with 11 meters and 5 meters, very easy. Okay, so we'll see here again two trapeziums having a length of the parallel sides 5 meters and 11 meters. We have seen this with the perpendicular distance of 4 meters, which is given, and a rectangle of 11 meters by 5 meters. We have also seen this. Okay, okay, then proceed. So total area will be the area of the trapezium, this trapezium, into 2 plus area of rectangle. Okay, then area of trapezium is given by this formula, half into h into a plus b into 2 plus l into b. Substitute, h is 4, so 4, 5 plus 11 into 2 plus 11 into 5. Okay, just substituting it. This is 16, this is 2, so 2 into 16 into 2 plus 55. So this is 16 into 4 is 64 plus 55 is 119 meters square. Very simple arithmetic calculations after substituting in the proper formula. Okay, so area of the octagonal surface is 119 meters square. Don't forget these units. Okay, so this, like that, was a very simple problem. Okay, move ahead. Fifth exercise. There is a pentagonal shaped park as shown in the figure. This figure, pentagon, 5 sides. For finding its area, Jyoti and Kavita divided into two different ways. Find the area of the park by both these ways. Can you suggest some other way of finding its area? Okay. So what they did? This is a pentagonal shaped field. This is 15. This is 15. This is 15, and this is 30. That is 30. So what Jyoti did? Jyoti divided this into like this. Though they are not seen equal, they are supposed to be equal. This is a rough sketch with this 15, this is given here, this 30, and this is parallel to this, and as this is 15, then from here to here the perpendicular distance or the height of this trapezium will be 7.5. Okay, so after explaining this, we'll go for the answer. Jyoti divided the figure into two trapezium with 15 meters and 30 meters length. That's what I said. Okay, of parallel sides and perpendicular distance of 7.5 meters, and there are two of this type. Okay, so the area will be area of one trapezium into two. Area of trapezium is given as half into h into a plus b into 2. That will be the area of the whole field. Now substitute. H we have seen it's 7.5. So this is equal to half into 7.5 into 15 plus 30. That is 45. Okay. Into 2. So this 2 goes with this. So what remains is 7.5 into 45. That is 337.5 meters square. Okay. So what Kavita did? Kavita did not do like this. She divided the field in this way, one triangle and a rectangle. Okay, now you know this is 15, this is 15 because that is given here, and this is 30. If this is 15, then what height is also 15. Remember that. Okay, so Kavita calculate by the area of triangle plus area of rectangle plus area of rectangle, and now we have base, we have height, we have length, we have breadth, everything. Okay, so area is half h into b of triangle plus l into b rectangle, that is equal to half into h is 15 into 15 plus 15 into 15. Okay, what is 15 into 15, and area of triangle is 15 into 15 and half multiplied by half. Okay, so that gives you this much quantity. This 7.5 into 15 is 112.5 plus this is 225, that is 337.5 meters square, same as this. Okay, student may try some other method also. If you can find it, then do write in the comment section. Okay, sixth one, exercise number 6. Diagram of an adjacent picture frame has outer dimensions equal to 24 centimeters into 28 centimeters. This is a diagram of a picture frame given, and what it says is this is 24 centimeters outer and this is 28. Okay, outer dimensions are 24 and 28, and inner dimensions equal to 16 and 20 centimeters. 16 centimeters, the inner is 16 centimeters and 20 centimeters. Okay, so besides this 28 is 20 and 24 is 60. Could have been other way around, it is not. Okay, find the area of each section of the frame. There are 4 sections: this, this, and this. Okay, find the area of each section of the frame if the width of each section is same. Width is not giving what it is, but it says width is same. That means this is same. Okay, so we move ahead for the answer. Look at the figure. Each section is a trapezium, and see, this is a trapezium, this is another one, this is another one, and what it says is opposite trapeziums are congruent. Okay, this is 28 and this is 20 and this is 28 and this is 20 and height is same. That means area of this will be same as area of this. Similarly here, this is 16 or 24, this is 16, this is 16, this is 24 and this is 4 or same. That means area of this will be same as area of this. And if you see, if from here to here is 24, 16 goes here, that means 4 is left here and 4 is left here as a height of this trapezium. Similarly, if you take this as 28 and if this is 20, then height of this is 4 centimeters as given here, and this is 4. So 4 plus 4, 8 plus 20 is 28, similar as this. Okay. So now we have the sides and the height, which is 4 centimeter. Now it is very easy to calculate. Okay. Perpendicular distance in both the cases are 4 centimeters. This we have seen. 24 minus 16 is 8 for 2 trapezium, and 20 is minus 20 is 8 for 2 trapeziums. Okay. So area of trapezium is half h into a plus b. Now we are calculating for this one. That is, now h for this is 4 and this is 16 plus 24. Simple. So if you calculate, this is 2 and 16 plus 24 is 40. So 2 into 40 is 80 centimeters square each. Okay. This is for one trapezium. Okay. And for another, formula remains same, half h into a plus b, or half 4 into, now this is 20 and 28. So this goes 2 and 20 plus 28 is 48. That is 96 centimeters square each. Okay. So like that, these are very simple problems. If you try to understand the data, what is given, and there may be some hidden data, or as you call it as hinge is given. Try to understand that, solve as many problems as you can, and you will be through it. Okay. Okay, so we move ahead. This is Dr. Bharat Parab helping you in your studies. If you have any difficulty in this topic of mensuration, let me know through comment section and I shall solve it. Thanking you. Good luck.